This is a forgotten research paper, and it's a bit like two angry goats agreeing to wear one oversized sweater for a second so they stop butting heads.
All right, fine, but just for a second. Deal! Anything to stop this headache.
Okay, let me explain. This is particle merging and splitting, a forgotten research work that almost nobody is talking about. And it can create all of these magical physics simulations where things smash into each other, things crumble, and more. Wow, can't believe I missed it too. But one of you fellow scholars found it and wanted to hear about it, and of course, your wish is my command. And if you stay for a bit longer, I'll show you the whole footage. We are also going to shatter a lot of things, and I'll tell you how it works. Now let's try to create realistic physics simulations of the world, and then... No, please don't do this to me. This is the intersection bug that still haunts so many video games and computer graphics systems. It's been way too long now. Enough is enough. And they found that all previous systems have this issue, it just depends on which case we are looking at. No perfect solution. Ouch. So, why? What is going on here? Well, common solid-solid collision handling techniques are based on force and impulse formulations, and these fail at resolving these kinds of collisions. Now, check out this new technique. If we do it with low velocity, correct, and now the harder experiment, higher velocity. Oh my, this still works. Absolutely amazing. Now, let's try solid-fluid collisions. Uh-oh, same problem with previous techniques. So, can the new technique help here? Once again, yes. But let's do some fracturing. I bet that it won't help here. With one previous technique, oof, that's rough. Let's forget this ever happened. Next technique. This is a bit of a milder case, but it doesn't make any physical sense. Third technique. Wow! So, this might be even more violent than the first. Okay, so why does this happen? Well, fracture simulations are super sensitive. So much so that if just one particle is much faster than the others, it can cause the whole object to instantly crumble. Now, hold on to your papers, fellow scholars, for the new technique. Ha! Now we're talking. Look at that beauty. Another important problem solved. So, how does all this black magic work? How is this even possible? Dear fellow scholars, this is 2-minute papers with Dr. Károly Zsolnai Fehér. The brilliant insight of the researchers here is to treat a collision not as an instantaneous event, but as a process that takes a small amount of time. Imagine two speeding roller skaters that are about to crash. And instead of bouncing off of each other, look, they grab each other and keep skating as a single, heavier skater. And later, they can separate easily. This is what particles do in this simulation. To be more precise, when particles touch, we merge them into one metaparticle for exactly one time step, storing any lost kinetic energy like compressing a tiny virtual spring between them. After integration, returning that stored energy. And bam! Finally, no crazy explosions and intersections can happen anymore. And it gets better. This temporary handshake also lets completely different simulators, solids, fluids, fractures, exchange information robustly. So that is why we merged these silly goats with the sweater. So let's pop the question. How fast is it? Let's see. Wow, goodness. The splitting and merging typically takes in the order of milliseconds, lightning fast, except this one. You would need this incredibly detailed simulation for it to even break a sweat. One word on limitations. It's not just one merging and splitting step, a fully robust implementation may double the simulation time. Totally worth it, but I wanted to point it out. Once again, genius work that almost no one is talking about, except here on 2-minute papers. And while we look at the full footage here, once again, it is incredibly hard to get YouTube to recommend this kind of content, but if every single one of you fellow scholars would press like and leave a kind comment, we could finally do more of this. We just tried it together and it worked. I had so much fun making this. People need to hear more about forgotten works like this, and if you help us out, you will get more of this. Here you see me running the full DeepSeek AI model through Lambda GPU Cloud. 671 billion parameters, running super fast and super reliably. This is insane. I love it, and I use it on a regular basis. Lambda provides you with powerful NVIDIA GPUs to run your own chatbots and experiments. Seriously, try it out now at lambda.ai/papers or click the link in the description.